What do you need my phone for? You're not taking it on the pig bus, are you?
You want to come see the pig bus?
In a little bit, yeah. Here, why don't you take my phone? Don't get on the bus with that. Don't give it to any pigs.
No promises!
Hey everybody, welcome back to AP Calculus AB. I'm Mr. Klein, and we're going to continue with limits today. I want to start by making sure that you understand how important the difference between these two words is. A value and a limit. Now, when we talk about the value of a function, we're saying what is happening to the function at a particular instant. And I'll phrase that as what happens to f of x at x equals c. Whereas when we talk about a limit, we're talking about what happens as we get close to that instant, but we don't care what happens at that instant. So this would be what happens as we approach x equals c, but not at x equals c. Well, why do we care about this? Let me give you an example. Suppose we got a function, and it's one of them piecewise functions, something like this. Suppose that it's equal to 5 minus x, as long as the x value is not equal to 2, but that it's equal to 7 when x is equal to 2. Well, in the case of this function, the value and the limit are not always the same. For example, here's time 2. I'm going to go ahead and graph this linear function, 5 minus x. I know that would go through, let's see, 1, 2, 3, 4, 5 right here. And then it has a slope of -1, so it's going to be headed that way. I'm going to stop right before 2. And then I'm going to continue right after 2. And the reason that I'm going to do that is because I know that at this instant, the first branch breaks down and we go to the second branch. And the second branch says that when x is equal to 2, the value of the function is 1, 2, 3, 4, 5, 6, 7. So if I asked you to give me the value, you would say, well, that's equal to f of 2. And f of 2 means plug 2 in here, which means we go to which of these branches is using my buddy 2. It's this one. The value is 7. Whereas if we were asked for the limit, we would say, well, the limit as x is approaching 2 of our function is whatever's happening as we get close to 2 over here and as we get close to 2 over here. What I see is that in both directions, this appears to be approaching 3. So the limit and the value, they are not the same. All right, let me give you a little bit of notation here. Okay, so suppose you're headed to a party. You think the party's right here. There's a party going on right here. Suppose that your friend is heading to a party. He also thinks the party is right here. When you get to the party, there is no party, there is no house, it's just an empty hole in the ground. I'm going to call this x value right here c. I'm going to call this y value right here L. I'm going to give you a statement. Here's our statement. It says that L, here's L right here, is the limit of this function in blue as it approaches C. That's what that says. If and only if you can make something as close as you want to something else by making something close to something. Don't worry about the but. I want to see if you can fill in those 4 spaces. And I'll tell you what, I'm actually going to give one to you. F of x. All right, so I'm going to be quiet for a moment. You pause the video, see if you can write this down, and then see if you can fill in those 3 spaces. All right, let's see if you've got it. You can make f of x as close as you want to L, right? Isn't that what we're doing? We're moving the value of the function closer and closer and closer to whatever L is by making the x value close to C. But the catch is, remember, there's a giant hole in the earth there, so we don't actually want to be on C. We'd say not equal to C. So that's like a formal definition of a limit. I want to mention one more definition to you so that you've got it as a reference, and that's this. We refer to what's happening on this side right here as the limit as x is approaching C from the left side. Does that ring a bell? A little negative means the left side of f of x. And then over here, as we move in this direction, we would say this is the limit as x approaches C from the right of f of x. And if you put those together, there's a rule, and that rule goes something like this. The limit in general, as we approach C of the function, exists if and only if, scoot up a little bit, the left side limit and the right side limit are equal to each other. So for instance, if I can do a quick example here. Suppose we had a curve and it's grooving along, boop, 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 and then all of a sudden it jumps up here. You can see that the limit from the left side over here, the limit as we're approaching, oh, it's 2 again, 2 from the left side of this function is equal to 2, and the limit as x approaches 2 from the right side of this function is equal to 3, and that means that the limit as x approaches 2 of the function in general does not exist. Hey, let's play around with a weird function. So suppose we got this. Weird enough for you? F of x is equal to 9, take away something, divided by the square root of that something minus 3. I want you to tell me the value at 9. I want you to tell me the limit at 9. So anytime you're trying to find the value, let's pretend to start here we don't have a calculator. Anytime you're trying to find the value, you would go ahead and plug that number into the function, which would give us 9 minus 9 over square root of 9 minus 3, which gives us 0 over 0, which is not a number, so the value is undefined. Okay. And you could just write down that value being undefined, something like that. Boom, done. Now, if this is 0 over 0, that's a big uh-oh as far as the limit goes. Because as you may recall from an earlier lesson, 0 over 0 means that we have an indeterminate form. And what that means is while we know that there is no value there, there is definitely a hole. There might be a limit. On either side of 9, it might be approaching something. Okay, so with that in mind, let's now pretend that we do have a calculator in our hands. I do quite literally have a calculator in my hands here. Okay, and with this calculator, I'm going to give you a few approaches for calculating the limit. Limit number 1 is going to be what I call the numerical approach, which means let's make a little table. Here's x, here's f of x, and I'm interested in the limits surrounding 9. So let's do something like this. Let's pick some values that are close to 9. So we'll do something like 8. And then I want to get closer than 8, so I'll go 8.9. And then I want to get even closer, so I'll go 8.99, one of my favorite prices. And I'm going to put those into the calculator, and I'm just going to see what happens over here for f of x. And that should tell me if there's a limit. So you're going to punch it into the calculator, and then you're going to click Second Table Set, and you're going to choose Ask right here. Once you've chosen Ask, you're going to go to the table, and let's punch in those values. 8, 8.9, 8.99. So I'm getting negative 5.828, negative 5.983, negative 5.998. If I were to go all the way to 9, what do you think is going to happen now? That's right, error. Don't ever write error on a paper. What you should put here is undefined. Okay, so what does that tell us? Does that tell us that the limit as x approaches 9 of the function is, these look like they're getting close to negative 6. Does it tell us that? No, not quite, because look at where these values are over here. These are all to the left of 9. So what it tells us is that the left limit as we approach 9 is equal to negative 6. If we want to know the limit in general, we need to play the same game over here. So let's go 10, and then 9.1, and then 9.01. Right, Odie? Yeah, you agree with me. So 9.01, 9.1, 10. Okay, and over here I'm getting negative 6.162, negative 6.017, and negative 6.002. So this is pretty strong evidence right here that as we approach 9 from what's called the positive side, the limit as x approaches is negative 6. All right, so what can we conclude from that? Well, if the left side's approaching negative 6 and the right side is approaching negative 6, then that implies that the limit as x approaches 9 in general, no positive or negative, of f of x is equal to negative 6. All right, so we've seen the numerical approach. I told you there would be 3 ways to take it to the limit. Here is the second one. Limit number 2, we could take a graphical approach. And what I mean by that is that you can quite simply grab your calculator, go to the window. Let's adjust this. For my min and max, since I'm interested in 9, I picked 2 numbers that are bigger than smaller than 9. Since I think the limit is negative 6, for my min and max here, I picked negative 10 and 0. And then I hit the graph. Okay, and once you've hit the graph, there's a nifty little button called trace right here. You should be able to hit that trace. And then as you move around, you'll get this little Space Invader guy. You can move really close to 9 over here. It's getting close to -6. And you can move really close to 9 over here. It's still getting close to -6. If I was going to draw a picture of the graph, if I asked you to draw a picture of the graph, I would want you to be, I would counsel you not to exactly copy what you see here. And specifically what I mean is that when you get to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9. On the calculator, there's just like a little open space, but you would want to include a hole to show that you know what kind of discontinuity that is. Okay, so there's another way that you can check what kind of limit you've got right there. Let me give you one last option. It was fun having this calculator, but let's pretend once again that we don't have it. On the AP exam for this course, you only get a calculator for about half of it, maybe even a little less than half of it. Okay. So this is called the algebraic approach. It goes a little something like this. Suppose we're asked to find the limit as x is approaching 9 of 9 minus x divided by the square root of x minus 3. And let's suppose that we've already plugged in 9 and found that we got 0 over 0. Well, then we need a strategy to evaluate this limit. And the strategy I'm going to give you goes a little something like this. When you have a square root and you don't like that square root in the denominator, you can't factor this one like you could the examples that we did last class. And so instead, what you're going to do is multiply by something called the conjugate. The conjugate of the square root of x minus 3 would be the square root of x plus 3. And of course, if you do that to the bottom, you have to do that to the top. Why? Because really, the only thing you're allowed to do to a function that won't change its value is multiply it by the number 1. So this over this is 1. Okay, so why do we do that? Well, check out what's going to happen in the denominator. I'm going to use a square to work this out. Square root of x minus 3 is multiplied by square root of x plus 3. Well, roots of x times roots of x is going to give me x. This times this is going to give me negative 3 roots of x. This times this is going to give me 3 roots of x. And negative 3 times 3 is going to give me a negative 9. So this cancels, and the entire denominator is just equal to x minus 9. Now, you are going to be tempted to do the same thing in the numerator. Don't. You'll see why in just a second. So this is equal to the limit as x approaches 9 of denominator is x minus 9. Numerator is 9 minus x multiplied by square root of x plus 3. Ooh! Huh? 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 What do you think? What do you think? What do you think? What can we do with those guys? Can we just cancel them out? No. But listen. Imagine we had a number, any number. Throw out a number. Shout a number into the air. I won't hear you because of how the internet works, but shout a number. I'm going to pretend the number you just shouted is 5. If I plug a 5 in here and a 5 in here, I would get, let's see, 9 minus 5 is 4. Over 5 minus 9 is negative 4. 4 over negative 4 is negative 1. Okay, give me another number. Any number. It doesn't matter what the number is. Shout a number. Let's suppose the number that you just shouted is 2. Now we would get 7 over negative 7, which is, guess what? Negative 1. So the moral of the story is that since this and this are opposites of each other, they are equal to negative 1, which means, oh boy, oh boy, oh boy, this whole statement would be the same as saying the limit as x approaches 9 of negative 1 multiplied by the square root of x plus 3. And now what we can do is we can take our 9, we can plug it back in. I'm going to do that right here. And we get negative 1 multiplied by the square root of 9 plus 3, which is, hot diggity dog, negative 6. The exact same answer that we got right here and right here.